A plus B is equal to B plus A, commutative law holds in case of sum or addition. This holds also in case of product. Already I have discussed in the last episode, but difference and quotient do not obey commutative law, as in case of real number system. Z1 plus Z2 distributive law for multiplication case, two cases, from left, from right, and in case of division, this one. Good afternoon, welcome to btosacademy, welcome to my maths class. I will continue today the topic complex number. Already I mentioned in the earlier episode. Before going into detail, let me mention things which are related to the earlier episode. I will mention those first. Already we have seen sum and product of two complex number, also the quotient of two complex number. I repeat, sum, difference, product, quotient of two complex numbers. In case of quotient, denominator is non-zero. All are also complex numbers. Accordingly, we must mention the laws which are followed by complex numbers. First of all, I write since all the results in case of sum, difference, product and quotient are also complex number, therefore we say that closure property holds. Closure property. if C, that specific C is set of complex numbers, rather universal set of complex number, then already we have verified sum, that means Z1 plus Z2, also difference product is also a complex number, then quotient of two complex numbers is also complex number. All these together is called closure property. I clarify, Z1, Z2 both are complex numbers and results obtained by taking sum, difference, product and quotient are also complex number. That means the results are in the complex number. This is closure property. Then commutative law. Means Z1 plus Z2, sum of two complex number will be equal to Z1 plus Z2, that will be equal to Z2 plus Z1. Already you have learnt in lower classes, in real number system, A plus B is equal to B plus A. Commutative law holds in case of sum or addition. This holds also in case of product. Already I have discussed in the last episode, but difference and quotient do not obey commutative law, as in case of real number system. Then associative law. Means Z1 plus Z2 plus Z3 will be equal to Z1 plus Z2 plus Z3 in case of addition. In case of multiplication, these are quite same as the properties in case of real number system. Then we have distributive law. Z1 within brackets z2 plus z3 is equal to z1 dot z2 plus z1 dot z3. I say from left this one. And from right distributive law. Then z1 plus z2 distributive law for multiplication case, two cases, from left, from right, and in case of division, this one. These are the laws hold in case of complex number also. Then number 5, additive inverse exists. Means if Z be a complex number, then Z plus negative of Z will give the complex number 0. That can be written as like this. Therefore, minus Z is the additive inverse of Z. It would be better if I mention this first. Existence of additive identity, that should be mentioned first. Additive identity. Means the number which when added to the given complex number, result will be the complex number. Means Z be a complex number. If we add with it the complex number 0, which can also be written as 0 plus I into 0, the result will be the complex number, sum of Z and 0. Then result is Z. That is why 0 is the additive identity. After this, additive inverse. The explanation of inverse of a number is that if we, in this case, add the number to the given complex number and the result becomes additive identity, then the number which added to the given complex number is said to be additive inverse. That is why first additive identity, 0 is the additive identity in case of complex number, and minus z is the additive inverse of z. These are the laws in case of addition, multiplication. Also in case of multiplication, these two, I rub this one, I call that number 7, multiplicative identity. Means if z be the complex number, the number which when multiplied with it, the result will be same, that means z. And we know if I multiply by 1, then the result will be z. Z say x plus iy, and this is 1 plus I. 1 can be written as 1 plus 0 into I. The result will be x plus iy. Students, you can verify it by actual multiplication. Therefore, 1 is the multiplicative identity of z. Then comes multiplicative inverse. Already we have verified if 1 by z is multiplied with z, since z is a complex number, it's reciprocal, that means 1 by z is also another complex number. If we multiply these two, the result will be 1. That is multiplicative identity. Therefore, 1 by z is the multiplicative inverse of z. These are the relevant properties in case of addition and multiplication of two complex numbers. Next item is the identities in case of number system, rather real number system learnt in lower classes. For example, a plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. AB that is equal to a plus b by 2 whole square minus within brackets a minus b by 2 whole square. Then 2 into a square plus b square is equal to a plus b whole square plus a minus b whole square, etc. These things, similar identities are also applicable in case of complex numbers. That means if z1, z2 be two complex numbers, then z1 plus z2 whole square, that will be equal to z1 square plus 2 z1 into z2 plus z2 square. As we have learned properties earlier, using those properties we can easily verify, prove those identities also.